Hey everybody, I hope you're doing well. In this video, I want to talk about the second number 4 problem about the particle moving along a straight line. So let me remind you what the problem is. So the problem is the second number 4 in here. I have a particle moving along a straight line, so its velocity is given by t squared minus t minus 6, and this is measured in feet by seconds. So there are 3 questions. I want to know the intervals that's moving, where the particle is moving forwards and backwards. And then I want to find the displacement and finally the total distance traveled. So I want to do all of my work in Mathematica here. I suggest that you try to write some of this down on a piece of paper to organize your thoughts on this. So the first thing I need to do is enter in the velocity function. So my velocity function is given by t squared minus t minus 6. So when I'm trying to figure out particles moving forwards and backwards, that's a velocity thing. So in this case, I want to set the velocity equal to 0 because that's going to tell me the places where this particle has stopped moving. So this isn't v prime of t, this is v of t because v is already velocity. And I am going to avoid any complex answers by putting in the reals. So if I evaluate this, I wind up getting 2 answers. T equals -2 and t equals 3. So usually when we're talking about a particle moving in a straight line, we do not concern ourselves with negative values of t. So I'm going to ignore the t equals -2 part of this. So I need to figure out between 0 and 3 and greater what the velocity is. So the easiest way to do that is to plug in a value that's between 0 and 3 and another value that's larger than 3. So I'll do that and I wind up getting -6 and 6. So what this says is that the particle is moving backwards between 0 and 3 and it's moving forwards on values greater than 3. So let me actually write that down so we can organize our thoughts here. So my velocity line, I'm going to start this problem at 0. And well, I don't have an ending time, but I do know that 3 is one of my critical values. That's where the velocity was equal to 0. I have a negative value between 0 and 3 for the velocity and a positive value for t values greater than 3. So the particle is moving backwards here and forwards here. Now if I look back at my question, well, I've kind of answered my question, well, at least part A. Now the displacement of the particle during the time period between 1 and 4, well, that really entails computing an integral. So let me write that down. So part B, well, this is part A. Part B is really asking us to compute this. And there are various ways to do this. So doing this by hand, I get t cubed over 3 minus t squared over 2 minus 6t evaluated between 1 and 4. So when I plug in the 4, I'm going to get a number. I plug in the 1, I'm going to get a number. So just to write all this out, it's going to be 4 cubed over 3 minus 4 squared over 2 minus 6 times 4. That's plugging in the 4. Minus plugging in the 1. That's 1/3 minus 1/2 minus 6. And whatever this turns out to be is going to be my displacement. So one really nice thing about this is I can do some of these calculations very easily. If I use the command integrate, I'm going to integrate the velocity function, where t is my variable. I'm going to evaluate this between 1 and 4. And let me suppress some of these so I don't need to see that. And I get 9/2. Oh, sorry, negative 9/2. So if I do all this, I should get negative 9/2 out of it. So that's my displacement. What does that mean? Well, it means that between 1 and 4 seconds, this particle has moved backwards a total of 4.5 feet. And that's my 9/2. I didn't say that was the total distance traveled. That's actually question C on this. So question C, I want to find the distance traveled. Well, what I do know is that I'm going backwards between 0 and 3 and forwards for values greater than 3. So for part C, I'm looking at the interval from 1 to 4. But that interval, 1 to 4, can be broken up from 1 to 3 and then 3 to 4. Because on this, I have my velocity is negative, and this one, my velocity is positive. So I have two legs of the trip here, between 1 and 3, and between, 3 and 4. So what is this going to give me? I want to go back to Mathematica really quick so I can do the calculations very, very quickly. So again, I'm going to use the integrate command. And I could do this all by hand if I want, but I'm choosing not to at the moment. I'm just saving some time here. So the first thing I want to go is from 1 to 3. And the second part, I'm going to go from 3 to 4. But what I'll notice here is that my output, 1 to 3, is negative 22/3. Now, to get a true distance out of this, I need to take an absolute value of this. Because I go back 22/3 of a foot, or 7 1/3 feet, backwards. So, but I still traveled that amount. The next part of this, again, I'm going to suppress that output. I'm going to integrate the velocity, but this time I'm going to go from 3 to 4. Oh, I forgot the t. I'm going to evaluate this and get 17/6. So this is going to get me 17/6. Now the total distance traveled is the sum of these. 22/3 plus 17/6. Whatever that turns out to be. Well, we can do this rather quickly. This is 44 plus 17/6. I'm just getting common denominator of 6. 44 plus 17 is 61/6. And remember, this is measured in feet. So I just did a little quick calculation at the very end. I hope you found this problem useful. If you have any questions, let me know. Have a good day. Bye.